Hi everybody, this is Eugene O'Loughlin lecturing computing at the National College of Ireland, and welcome to my series of short how-to videos. In this video we're going to learn how to perform a chi-square test, also known as a goodness of fitness test, and we're going to learn how to do it by hand. So first, let's take a look at a typical problem that chi-squared can help us to resolve. Let's say we have a poker machine that's supposed to deal cards at random from an infinite deck. In a test, you counted 1,600 cards, and we observed the following number of cards in each of the four suits: 441 hearts, 404 spades, 402 diamonds, and 353 clubs. Those four numbers added together will give me 1,600. And we want to know, could it be that these suits are equally likely, or are these discrepancies too much to be random? And in a chi-square test, we want to be able to test to see if there's a significant difference between these observed values that you see here and the values that we would expect in an experiment like this. Now the formula that we're going to use for chi-squared is as follows. So this is my symbol here, chi-squared. It's equal to the sum of our observed, difference between our observed and expected values, O minus E in here, squared, divided by E, our expected values. So as you can see, we need just two values to help us determine chi-squared. O for observed, which we get from these values up here, and E for expected, which we will determine in a moment. So before we start, let's outline our null and alternate hypothesis. Our null hypothesis is that the proportion of hearts, H for hearts, is equal to the proportion of spades, is equal to the proportion of diamonds, is equal to the proportion of clubs. My alternative hypothesis is that they are not the same. So just putting in the not equals to sign here. And in a chi-square test, our null hypothesis test tells us that there is no significant difference between the observed and expected values. And our alternative hypothesis is that there is a difference, so that at least one or two of those are going to be different. And we're going to operate here at an alpha value equal to 0.05. So we're now ready to go and start to build up these values here, and I'm going to do this in a table. So first of all, let me put down my observed value. So O for observed, so write in my hearts, spades, diamonds, and clubs. And my observed values are simply the four values that I have up here. So I'm going to put in 441 hearts, 404 spades, 402 diamonds, and 353 clubs. So I can take away my question there now, give myself a bit of space. And next we have to put in our expected values. So that's going to be designated with an E. And as we have four suits here and we have drawn 1,600 cards, we would expect each suit to occur 1,600 divided by 4, which is 400. So we would expect exactly the same number of cards to be determined if they are drawn at random. So each of these two rows here adds up to 1,600. So now we have the two values we need in our formula, so let's go ahead and work out the calculations. So first of all, let's do O minus E, and that's the difference between the observed and expected. You can do E minus O if you want, it doesn't matter which way you do it. So I'm going to do these first calculations in my head. 441 divided by 400, take away 400 is 41. 404 minus 400 is 4. 402 minus 400 is 2. And 353 minus 400 is minus 47. Next we can see in our formula that we need to square that value, so let's do O minus E squared. So I need my calculator for that. So first of all, it's number 41 squared. That's 1,681. 4 squared in my head is 16. 2 squared is 4. Minus 47 squared is 2,209. The next part of the calculation is we need to divide that number by the expected value. So for hearts, that's going to be 1,681 divided by 400. So let's write that in, O minus E squared divided by E. So 1,681 divided by 400 is 4.2 rounded. Next is 16 divided by 400. That's equal to 0.04. 4 divided by 400 is equal to 0.01. And the final calculation for clubs is 2,209 divided by 400, which is equal to 5.52 rounded. So we've 4 groups here, so we've now done this formula up here 4 times, and now we need to sum them all together. So add these 4 numbers up. So let's go ahead and see what the sum of those 4 numbers is. So 4.2 plus 0.04 plus 0.01 plus 5.52 is equal to 9.77. So my calculation here, my chi-squared value, is equal to 9.77. So that's what we've worked out in this formula up here. Next we need to determine a critical value from our chi-squared distribution table. So we have a distribution, something like this, for chi-squared, and in the right tail we need to know what this critical value is going to be here at alpha equal to 0.05. So to do that, we need to determine first of all the degrees of freedom. So our degrees of freedom is going to be the number of groups minus 1. So that's 4 minus 1, so that gives me 3. So 3 degrees of freedom. My alpha value, already worked that out at 0.05. So I'm now ready to look up my chi-squared distribution table, which is looks like this here. So I have right across the top, I can see what my probability is. So it's 0.05 I have chosen. And the row I get, it gives me the number of degrees of freedom. So where they intersect, a value of 7.181 occurs. So that's my critical value. So my critical value is equal to 7.81. So here I can write in 7.81. We can see that my chi-squared value exceeds that, so now it's time to report and make a decision. So we report like this: chi-squared for 3 degrees of freedom, it's equal to 9.77, and her probability was set at 0.05. So that's how we report our result. We can see here that our chi-squared value is greater than our critical value. So our chi-squared value is going to fall into the rejection region over here, 9.77. So therefore our decision is that we reject our null hypothesis. So we're rejecting our null hypothesis that there's no difference between the observed and expected, in favor of the alternative hypothesis is that there is a difference. So in this particular instance here, we have found a difference, and we might, for example, be concerned about the poker dealing machine, that it's not dealing out cards at random. So that's how you conduct a chi-squared test by hand. I hope you found this video useful. Thank you for your attention.